You know this moment. You've got 20, 30, 40 tabs open. You'll read them eventually, and then it happens. You click a tab, and it just hangs. The whole machine goes syrupy. Typing lags. Switching windows takes a second that feels like 10. And here's the strange part. It's not just the browser that's slow. Everything is. Your music stutters. Your mouse jumps. So what is it about opening a few more tabs that brings the entire computer, one that does billions of things a second, to its knees? Start with what a tab actually is. It's tempting to think of your browser as one program. It isn't. Every tab is walled off from the others, its own little sandbox, running its own code, holding its own stuff. The page's text and images and whatever JavaScript the site is running. Browsers do this on purpose, so one broken tab can't take down the rest. But it has a cost. Each of those sandboxes needs memory to hold everything it's juggling. Often hundreds of megabytes for a single busy tab. So 30 tabs isn't one program, it's more like 30 hungry programs, all wanting a slice at once. Now, all that stuff has to live somewhere fast, because the processor can only work on data that's sitting in RAM, main memory. We saw that a couple videos back. RAM is the workbench everything active has to be laid out on. And here's the catch that everything today runs into. The workbench is a fixed size. 8 gigabytes, 16, 32, whatever you paid for. That's the ceiling. Your tabs share it with every other app you've got open, and with the operating system itself as well. Open enough, and together they ask for more room than physically exists. So what happens when you hit that ceiling? Here's the thing. No program is ever told. Every program on your computer is handed what looks like its own private, enormous stretch of memory, all to itself. That's a lie the operating system tells on purpose, and we did a whole video on it. Behind the scenes, the OS is secretly mapping each program's make-believe memory onto the real, limited RAM chips, one page at a time. As long as there's room, you never notice. But when the real chips fill up and yet another tab asks for memory, the OS can't just say, "Sorry, we're full." It has promised otherwise, so it has to make room. Now, the way it makes room is quietly brilliant, and it's the root of everything you're feeling. The OS looks for pages of memory that haven't been touched in a while, like some tab you haven't looked at in 10 minutes. And then it copies them out of RAM onto your disk, your hard drive or SSD. Windows calls that file the page file. And on a Mac or Linux, it's called a swap. Same idea. Disk becomes an overflow bin for memory. Now, that page's spot in RAM is free, and the OS hands it to whoever needs it. This is the trick that lets RAM feel bottomless. It isn't. It's just quietly borrowing space from a disk that's hundreds of times bigger. And of course, there's a catch. The whole reason that this hurts. RAM is fast. Reaching a piece of data in RAM takes about 100 nanoseconds. Reaching it on an SSD, around 100 microseconds. That's roughly 1,000 times slower. 1,000. On an old spinning hard drive, it's more like 100,000 times slower. So let's make that real. Back in the CPU video we created, we slowed time down so one clock tick became 1 second. And at that scale, a trip to RAM takes about 5 minutes. On that same scale, fetching a page back from SSD takes about 3.5 days. From a hard drive, better part of a year. That's the cliff your data just fell off the moment it got pushed to disk. And now the crawl makes sense, right? You click a tab you haven't touched in a while, but its memory isn't in RAM anymore. The OS shoved it out to disk to make room. So the processor asked for it and it's not there. That's called a page fault. And everything stops while the page is dragged back from disk. That 5-minute, 3.5 day trip. And to fit it back into full RAM, the OS has to evict another page from whatever you were just doing. So the next thing you touch isn't there either, and the whole cycle repeats. Every click pays the disk tax. Push it out far enough, and you hit the point that has a name. It's called thrashing. When the memory you are actively using is way bigger than the RAM you have, the OS can't win. Every page it brings in forces another one out, and that one's needed a split second later, so it gets dragged back, kicking out yet another. The computer ends up spending almost all of its effort just moving pages between disk and RAM, and almost none of it actually running your programs. And here's the twist. Your processor isn't overworked. It's mostly sitting there waiting on the disk. Exactly like the waiting problem for the CPU video, but 1,000 times worse. The machine looks frantic. It's actually stuck. So nothing is broken. Your computer isn't weak and it wasn't badly made. What happened is simpler and kind of beautiful. You quietly asked for more memory than you physically have, and the OS did the only thing it could. It started borrowing from the disk, a disk that's 1,000 times slower. That's the whole crawl, which is why the fixes work the way they do. Closing tabs doesn't clean anything. It just shrinks what you're actively using back under the RAM ceiling, so nobody has to touch the disk. More RAM raises the ceiling. It's even why your browser now quietly puts old tabs to sleep and reloads them later. Same idea every time. Keep what you're using small enough to fit. Once you can see the cliff, the whole thing stops being mysterious and starts being memory. Everything you just figured out rests on something deeper, and that's the next video, so start there. Would you rather understand your computer than just use it? Then subscribe, and I'll see you next time, further down the stack.